Good morning. Welcome to Math 1180. We got a whole bunch of work to do with algebra this year. So, my name is Professor Lindquist, and this is our very first lesson of the year. Each and every single lesson that we do will be recorded onto a video. I will put it up on YouTube and provide a link for that video in case you should miss class, in case whatever we cover doesn't make sense the first time you see it. In case you want to get together with a group of friends and watch the video as a group to bounce ideas off of each other, whatever it takes. The whole idea is I take my job extremely seriously. And what I need to do is create a class structure and have a way of presenting material that helps you become the best that you can possibly be, both as a student in general and in mathematics in particular. So, you'll see certain things that I go over many, many, many times. You're going to see a structure to class. You're going to see, an introduction to class. You're going to see that we constantly go over work that you did. You're going to see that we never, ever teach a topic once. I have a pet peeve. I taught public school for 33 years. I have tutored forever. I've been teaching at Centenary now for 1 year, and the kids have all done well. By and large, the only kids who did not do well did not do their work, and we'll talk more about that at a later point in time. But anybody who's done their work has definitely passed with a vast majority of A's and B's, high B's. So that's what we're going to get going on this and introduce you into how to be a successful student for all of your classes, math included. I understand that some students have never really done well with math, and I think that's going to change. I think you're going to do really well during the course of the semester and see some value in it, more so than you would have in the past. So, whenever you hear this, that means the ice in my drink is banging into each other. I don't drink alcohol. I do, however, drink this drink called BAI, and I mix it with water and ice, and I drink it during class. So that's what you will hear when that is going on. As far as who I am, a little bit of a quick introduction. I am from Long Island in New York, and a little town called Bayport. I was really blessed to go to an amazing high school and be surrounded by absolutely brilliant people, and that's not an understatement. I truly was surrounded by brilliant people. I majored in mathematics. I minored in both physics and education. So I actually have a little bit of experience teaching that too. As far as my interests go, I absolutely love fly fishing. Now I live in a town called Callicoon, which is in upstate New York. I am about 2 hours from North Jersey. And I also love photography. I had a dog photography business. I don't do it much anymore. But I also love landscape photography and particularly fly fishing photography and a little bit of sports photography too. So those are the things that I really love. And I love to learn and I love to think. And mathematics is a great way to view the universe. And that's what we're going to try to do. So a little more introductions. There's me fly fishing on the Delaware River. I actually have one of those boats. It's called a drift boat. I'll be out on it as often as I can be. A little more fly fishing. That's up on the Salmon River by Pulaski, New York. There's one of our dogs. That's Ducky. He's a miniature Australian Shepherd. You can see in all of these pictures the photography coming out. It's another one of our dogs, Bauer. He's a Central Asian Shepherd. And my wife. More of my wife, and another one of our dogs, a Central Asian Shepherd named Ziva, and she is the most award-winning, decorated, successful Central Asian Shepherd in the history of North America. Now, math frustration is a very real concept. It can drive you crazy. What are some of the things about math? I think that a lot of times people get stressed about the results and the outcomes. And one of the really important things to learn is the process is what you should be focused on. How you go about your business. And we will talk so much about this during the course of the year that we will be crystal clear on it. But how you go about your business, if you do that the right way, you're going to be in great shape. Now, what I want to do at this point, though, is I want to talk about a moment that was revelatory to me. It was a cathartic moment, apocalyptic almost. I was working on a treadmill one day at a gym, and as I'm doing this, I'm getting warmed up. You know, nice, easy stuff. And there's a singer by the name of Don McLean. Now, you all probably know one of Don McLean's songs. Bye bye, Miss American Pie. Drove my Chevy to the levee, but the levee was dry. Well, you can also see now why I don't teach singing. So, as I'm getting warmed up, I'm listening to this song called Vincent, and he is describing the struggles of Vincent van Gogh in his life as an artist. And I realized some things. But before we get going, in case you never heard the song before, this is the song Vincent. Oh, trying to start the song up here. Where are we here? Maybe it's over here. Oh, why isn't it playing? Oh man, how do I get the song to play? Ooh, interesting. Why isn't the song playing? Oh, I think there was a YouTube link here. So I'm going to do something a little bit different. I'm going to put the song up from YouTube. Okay? So I'm going to end the show and then come back to it. Ready? I don't think this is going to play. No, I don't understand why it's not going to play, but that's okay. No big deal. We're going to go back to Fibonacci sequence. There we go. Ready? Remember, this is about math perception and what we see. And it even hinted at the meaning of life right there, which is very much what I get into about math.
1, 2, 3, 5, 8, 13, 21, 34, and continues indefinitely. Each number is obtained by adding the last two digits together. If we were to take a perfect or golden rectangle, break it down into smaller squares based on Fibonacci's sequence, and divide each with an arc, the patterns begin to take shape. We begin to see Fibonacci's spiral. The spiral in and of itself is insignificant. Its importance is revealed in where we find it. Take, for example, the sunflower. The display of its florets are in perfect spirals of 55, 34, and 21, the sequence of Fibonacci. The fruitlets of the pineapple create the same spiral based on the sequence. The pine cone does the same. As currents move through the ocean and the tide rolls onto the shore, the waves that bring in the tide curve into a spiral that can be mathematically diagrammed onto a plot at the points 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Buds on trees, sand dollars, starfish, petals on flowers, and especially the nautilus shell are formed with this exact same blueprint. With each segment of growth, the nautilus adds to itself one more value on Fibonacci's scale. This blueprint can be seen around us on a small scale every day, but the greatest example of all is directly above our heads. At an average of 100,000 light years across, even the spiral of the galaxies above us are formed with the exact design that the tiny shell is formed. This sequence, or blueprint, appears to be the trademark of a designer.
So what we see here is that there's, excuse me, there's this math all around us in the world. And like I said before, what I realized is that like Vincent van Gogh tried to get the world to see what he perceived, this math course will be about getting you to perceive what I perceive. So, radical. So, what exactly is an algebra? When you were in middle school and high school, you took this course called algebra, and I'm willing to bet your teacher never ever once told you what an algebra was. What is it? So, an algebra is a system, it's a structure. It's a lot like the United States Constitution, a sport, building codes for new homes. An algebra, in the mathematical sense, is a system that we follow. It's a constitution of sorts, for reasoning our way with variables that represent ideas, notions, or quantities that are often in the world around us. It's kind of like a mental sport. Like, when you look at a sport, you have players and you have rules and things you go by. Same thing with an algebra, same thing with the Constitution. In the Constitution, you got citizens and laws and so on and so forth. In an algebra, you are dealing with ideas and variables and principles that they follow and things we try to prove. So we need to know that certain principles or codes of standard to make sure our conclusions are valid. Kind of like ensuring that our mental structure or our building will stand when it is put to the test. Okay? As a sport starts with players, and algebra has players too. Some of these are called variables and expressions. For instance, maybe I want to build a small development of homes. Let's say I don't know how many windows I'm going to need in total. I don't have to order the windows, so I will have to order the windows, so I just have to keep track of it. But I do know that there are 12 windows in every house. So this much I know. If I take the number of houses and multiply by 12, I can figure out how many windows I'm going to need. I can't give you an exact number of houses, but I don't want to lose my train of thought. So in algebra, we have our players. A variable, for example, x, and an expression, in this case 12x, because every single house requires 12 windows. So I'm going to do the number of houses and multiply by 12. So for instance, if there were 2 houses only built, 12 times 2 is 24. I would need 24 windows. But if there were 10 houses built, 12 times 10 is 120. Are there better answers? Well, why are we not going to the next slide here? There we go. Okay. Now we're there. Ready? Variables in algebra. Algebra uses letters such as x and y to represent numbers. Okay? In the last problem, we used a variable like x to represent the number of windows in a particular house. I could have used w too. Probably would have made more sense. If a letter is used to represent various numbers, it's called a variable. And that's the big thing, and you will be asked about this on your homework. Variables can change. They do not have a set value. Examples of variables: x, y, z, a, x sub 1, that means x with a subscript of 1, x sub 2, and so on. Variables are normally represented with letters of some kind, not with numbers. Numbers are generally constants because the value of a constant does not change. Once again, the value of a constant does not change. All right, so suppose you're building homes in a different development. This time you know every home is going to get 15 windows, but you don't know how many homes there are. Write a variable for the number of homes in an expression for the number of windows. Okay, so the first variable you're going to put down is the number of homes. And then you're going to use that variable to make an expression. An expression is something like 3a, or c plus d, or c plus 5, or 10d. Those are all examples of expressions. Expressions have variables in them. So the first thing you want to do is write a variable for the number of homes and an expression for the number of windows. Now, just one thing about these videos. I don't really pause on the videos like we would in class. The reason I don't do that is I don't have all day to get these videos up on YouTube, and I don't want a lot of dead air in there. So I pause for a couple of seconds, and then I give you the answer. If you're watching this video, like tonight's the night before our class starts and I'm recording this video, and one of the guys in class was saying, hey, look, I go to soccer games sometimes and I'm going to miss class. So it's great for him to watch these videos. And what I would suggest that he does is he watches the video as if he's going to class. And when I ask this question, write a variable for the number of homes and an expression for the number of windows, pause the video. Write down your answers on a piece of paper, then resume the video. See if you got it right. Do that every time I ask questions in here. Now, that means that these videos are going to be shorter than class actually is, from in the sense that class might be an hour and 30 minutes long, and the videos, are probably only going to be 45 minutes long, okay? But that's because I'm leaving you time to answer the questions. So the variable for homes, you can pick any letter, but I think a really good one would be H for homes. And the expression for the number of windows, I would go with 15H, okay? Now, an algebraic expression is a combination of variables and numbers using the operations of adding, subtracting, multiplying, and dividing, and you could use powers and roots as well. These are all called algebraic expressions. Okay? So, the difference between an expression and an equation has an equal sign. Expressions never have an equal sign. All right, suppose you're building homes in yet another development. This development has style. So each house has two different types of windows. There are casement windows and there are double hung windows. You do not know how many windows each house will have, but this time you know there will be 25 homes. Okay? So we don't know how many windows this time, but we do know the number of homes. So, write an expression for the number of casement windows in the development. Then, write an expression for the total number of double hung windows. Then, write an expression for the total number of windows in one home. Then, write an expression for the total number of windows in the development. Go ahead, give it a shot. Now remember, you should be stopping the video, answering the questions, and then restarting the video. I call that stop and start. Okay, so the first one is 25C, because you know there's going to be 25 homes, and we're going to use C for casement windows. So the number of casement windows in an individual home is C, and 25C represents for the entire development. Now, the number of double hung windows, 25D. Again, there's D double hung windows in a house. I don't know how many. Multiply it by 25. Now, you could have used X and Y or H for double hung, whatever you wanted to. But as long as you use different letters for each, you're in good shape. Then it says write an expression for the total number of windows in one home. In one home, it's going to be made up of casements and double hungs. So you add them up, C plus D. And then for the total number of windows in the development, well, if one home has C plus D and there's 25 homes in the development, we have to multiply. So the best way I think of to write this answer is at the end there, 25C plus D in parentheses. That means you figure out how many windows are in one home, then multiplied by 25. But you could also figure it as, I got to do part one, which was how many casements, and part two, which was how many double hungs, and then I can add them up for 25C plus 25D. Okay. All right. I don't know why it's not moving forward here. Come on now. What the heck? I don't know why this is not moving forward. Huh. Very, very, very strange. I'll stop it and start it again. Okay, now, variables and expressions in algebra, the next part of what we're going to do. So we'll do a few more slides and then I'll put up. Okay. So, next one up. Suppose you're building homes in yet another development. This one has style. So each house has two different types of windows, double hung and bay windows this time. Oh, there's casements, double hung, and bay. So three different types. You don't know how many windows each house will have, but this time you know there will be 15 homes, not 25. So, write an expression for the number of casement windows, then for the number of bay windows, then for the total number of windows in one home. Now keep in mind, we also have double hung there, and Write an expression for the total number of windows in the development. So, first up, remember stop and start here. 15C for 15 times the number of casements in a house. For the number of bay windows, it would be 15B for 15 homes and B bay windows in each house. Now, total number of windows in a single home, casements plus double hung plus bay. So C plus D plus B. But usually, for reasons that will become apparent later, we try to follow alphabetical order. So you're better off writing B plus C plus D. And then last but not least, in the 15 homes, well, you could add up parts 1 and 2, and then of course the 15 double hungs. Or you could just say in one home there's bays, casements, and double hungs, add them all up, and then multiply by 15, which is the second way to express that answer. Okay. Suppose your weekly income is $1,500. You have the following expenses: cars, meals, movies, and tuition. Assign a variable to each expense. Stop and start. Okay, so the first thing we're going to do, car we'll call C, meals we'll call M or M1. Movies we'll call V or M2. Now, if I call meals M, I can't use M for movies. That's why I either go to V or to M2. And tuition, we'll do that for T. Write an expression for the total weekly expenses. All right, so that would be C plus M plus V plus T, or C plus M sub 1 plus M sub 2 plus T. So these variables just represent things, and we just do with them what we would have done with the numbers. We would have added the numbers, so now we're going to add the variables. Okay? Write an expression for how much money after expenses remains every week. Remember, you start with $1,500. How much do you have left after expenses? Remember, stop and start. Okay, so you start with $1,500, and then you have to subtract the expenses, which are C plus M plus V plus T. So I put all of that in parentheses. Okay. All right. We went through each of these already. Variables and expressions in algebra. Next and last question before we kind of segue into a little bit of review and building on that review. Your company is building a product to sell. Each unit requires the following parts: 8 pieces of wood, 32 bolts, 32 nuts, and 2 springs. You sell U units. First question, write an expression for total number of pieces of wood needed. Remember, you sell U units, and each unit has 8 pieces of wood. So what would be the correct answer to that? Then it asks, what's the total number of nuts and bolts needed? Remember, there are U units, and there are 32 bolts and 32 nuts. Then, what's the total number of parts needed? Okay. All right. So stop and start time. Okay, so first up, the number of pieces of wood. Well, each of the units has 8 pieces of wood, so that's 8 times U. Next up, nuts and bolts. That would be 32U plus 32U. In other words, each unit, there are U units sold. I got to multiply it by 32 for the bolts, 32 for the nuts. I could do 32U plus 32U, but let me ask you a question. If you had $32 and $32, wouldn't you have $64? And if you had 32 puppy dogs and 32 more puppy dogs, wouldn't you have 64 puppy dogs? So if you have 32 U's and 32 more U's, that means you have 64 U's altogether. That's to confuse it with My Cousin Vinny, where it's 32 Utes. But if you didn't see the movie, you don't understand what I just said. If you did, that's pretty funny. The total number of parts needed, that means I have to add up the wood, the nuts, the bolts, the springs. All right. So at this point, I'm going to pause this video and we'll make a new one, and then we'll start up and we'll put that on the internet too. So for now, pause.